just having fun, man. What's
Hey everybody, we are here for our first flipped video. Today's lesson is on 3.1, Chapter 3, Section 1, over functions. So I guess the first question you're saying is, what is a function? Well, first off, let's start with the word relation. A relation pairs inputs with outputs. When a relation is given as ordered pairs, the x-coordinates are inputs and the y-coordinates are outputs. So everybody should be familiar with an ordered pair: 2, 3, 6, 8, 4, 20. That x-coordinate, that first coordinate, that's your input. That second coordinate was a y-coordinate, that's called your output. So you're going to put in an x, and then as a result, into a function, you will get out a y, which is going to create, it's a coordinate. Well, so anytime you have a set of ordered pairs, that's just called a relation. A specific type of relation, though, is called a function. So it says a relation that pairs each input with exactly one output is a function. So I always say every x can have only one y, and you can't have repeated inputs or x-coordinates. So for example, I can have 4, 1. I can also have 3, 1. I can have 2, 1. All of them, they can have the same y because it is unique to that one x. But the minute you start having 3, 1 and then 3, 2, that becomes not a function because now we have the same x that is being paired with the same y. Or in this case, the same x to a different y. So again, if we want to think of it as a picture, I've got 3, oops, get this going here for you. Let's pick color here, and let's go. Let's get my stylus working here. We're drawing and nothing's coming out. Okay, it was working earlier. There we go. So let's try 4, 1 and 3, 2. Okay, I have two different inputs. I have different outputs, but the fact is each x has one y. But if I have 4, 1 and I've got 4, 2, so this is a yes, that is a function. This is no, that's not a function. Because this 4 goes to 1, and 4 again also goes to 2. So 4 goes to 1, 4 goes to 2. Well, every x can only have one y it goes to. So 4 goes to 1, 4 can't go to anything else. That's not a function. Okay? So we will kind of explore more of this as we go forward, but that's just a real quick look at function, not function. Again, you're going to do this on your own, not with a partner. It says functions can be described in many ways. We just talked about a set of ordered pairs. Okay, so that part we already covered. Also, functions usually are going to be written as like an equation. There's an input-output table we'll show you. Also in words, you can do it with words. You can do it also with a graph. These are all different ways to represent a function. For this particular one, it says explain why the graph shown represents a function. Well, the reason again then is going to be because I have 0, 8, I have 1, 6, I have 2, 4, and I have 3, 2, and finally I've got 4, 0. Well, if you look here, every single x value is unique. I have a 0, a 1, a 2, a 3, a 4. There's no repeats. So every x has one y that it goes to. We're not having 2 go to another y value besides 4. We're not having 3 go to another y value besides 2. So this is just another example of a function. Okay. Determine whether each relation represents a function. Again, we are going to look for repeats in the x. So right here, I've got 0 goes to 8, 1 goes to 8, 2 goes to 8, 3 goes to 8, 4 goes to 8. Although they all go to 8, every x, though, still has one y value that it goes to. Even though it's the same y value, it still has one y value Each input has one output. So that is a function. It doesn't matter that they all have the same output. It's the fact that every input has just one output. So I'm going to go yes for A. That is a function. Well, for this one, though, this one is a problem because 8 goes to 0, but now 8 goes to 1, and 8 goes to 2, and 8 goes to 3, and 8 goes to 4. Well, 8 can only go to one y value. So if 8 goes to 0, 8 can't go to anything else. So because of all these other ones, 8 can't go to any of those other ones. Well, it can, but if it does, it's not a function. So to be a function, every input can only have one output. Each individual input has one output. That does not happen on B. It does happen on A. So that is a function. Okay, so again, let's try a couple more here. Again, on your own, this is going to be an input-output table, and we're going to use arrows. So again, 1 goes to 8, 2 goes to 9, 3 goes to 10, but 3 also goes to 11. So because of this, this is not a function because 3 goes to 10 and 3 goes to 11. 3 can only go to one output, not two different outputs. So that's not a function. If we look at this one, again, I've got 0, 8, 1, 6, 2, 4, 3, 2, 3, 4. Well, there's a problem here because 3, 2 and 3, or excuse me, not 3, but 4, 2. That's good. So far that's okay. That's good. But as we progress, you're going to see there's a problem right here. And that problem is my top one is going to be 5, 5. But this one is going to be 5, 4. And that is a problem because 5 goes to 4 and 5 goes to 5. That is not a function. 5 can only go to 4 or 5 can only go to 5. 5 can't go to both. So that's a problem. We also have a problem over here because right here I've got 7, 5, but I've also got 7, 8. Well, that's a problem. 7 goes to 5, so 7 can only go to 5. 7 can't go to something else. 7 can't go to 8. So that's actually two reasons here why this one is not a function. So neither one of these for C or D are functions. So be prepared for things like that. Okay. Also, we have a list of ordered pairs. So we're going to do the same thing here. I look for repeat x's. So I've got a -2, a -1, a 0, a 1, and a 2. All those x's are different. So that means every x has one y. And because of that, this is a function. Now I look for repeats for f. -2, -1, -1. Uh-oh. These two are repeats. -1 goes to 0, -1 goes to 1. That is not a function. Not a function. Okay. Each radio frequency x in a listening area has exactly one radio station y. Okay, well this one's kind of different. We don't really have numbers. So kind of what they're talking about here is this is a function because each input frequency is paired with exactly one output radio station. So each radio frequency x in a listening area, it says it has exactly one radio station. So that exactly one is they're pairing x to one y. So this is a function, even though they don't have numbers. The wording of it helped us. Where this one says the same television station X can be found on more than one channel Y. Well, that's a problem. That's not a function. So again, the input each input television station is paired with more than one output. So every X can only have one Y. It can't have more than one. So that would be an example of no. The next one is actually not a function. When you see X equals 2, it's just an equation. So what that means is each input value of 2 is paired with every possible output value of y. What that means is if I actually graph this, it would look like this. This is 1, and this would be 2, and this would be my line. And if you notice, there would be a ton of points on this line. Every point on this line is going to be 2, something. So I could have 2 comma 1, 2 comma 2, 2 comma 3. Every one would have the same input and then a different output. But again, 2 can only go to one number. 2 can't go to multiple numbers. So x equals 2 is a vertical line, and a vertical line will always not be a function. It will never be a function. Okay? Always not means never. Sorry, bad choice of words. But x equals 2 is vertical, and that will never be a function if it's vertical. Horizontal lines are good. So if that was y equals 2, it would be a function because that's a horizontal line. That would actually look like this. But x equals 2 would not work. And then finally for j, this is going to be a function. And the reason why this is a function is because every input value of x is going to be paired with one output value of y. Meaning if I put a 1 in for x, I'm going to get 2 times 1 is 2 plus 3 is 5. So that would give me 1 comma 5. If I put a 2 in for x, 2 times 2 is 4, 4 plus 3 is 7. So every number I put in for x is going to be unique, and it's going to give me a y value. So if I put in a 1 for x, I'm going to get a 5 for y. I can't put a 1 in for x and get something different besides 5. So every x is going to have one y. We'll do one more. If I put a 3 in for x, 2 times 3 is 6. 6 plus 3 is 9. So every x would have one y value here. This is an exact answer. This is a function. Okay, we're going to let you try these on your own. So I want you guys to hit pause. Go ahead and hit pause and then try these ones on your own. And then when you're ready, just hit play again and then just check your answers. So go ahead and hit pause. Okay, hopefully you tried these. Hopefully for letter A here, you realize this is a function. -2, -1, 0, 1, and 2. Those are all unique different x values. So there's going to be no repeats in x. So it doesn't matter that the y values have a 2, a 2, a 2, a 0, and a 0. That part doesn't matter. It's the fact that every x has one y, and that's why it's yes. For the second one, that's a no. 4 goes to 0, 4 goes to 3. Cannot have that. That is not a function. If we look at C, C is also going to be a no because 0 goes with 5 and 0 goes with 6. So because of that repeat x with a different output, this one is not a function. And then over here, I like -1 going to 4. I like 3 to 15. I like 11 to 15. So this is a function. Every x has one y value that it goes to. Even though these two go to the same y value, they still have one y value that they go to. So that is a function there. Okay, we have something now called the vertical line test. So it says a graph represents a function when no vertical line passes through more than one point on the graph. So at any point on a graph from now on, if you just draw any vertical line, it has to be straight up and down, can't have like slanted, it's got to be a vertical line. If the vertical line only passes through or touches one point, it's a function. If the vertical line passes through the graph and it touches more than one point, for example, this one intersects the graph twice, if it intersects it 2 or more times, it's not a function. If it only intercepts or touches the graph once, it is a function. Okay, so that's called the vertical line test. So let's try it here. Determine whether each graph represents a function. So let's try it. Here's a vertical line, and it passes through or touches the graph twice. That's bad. Over here, it touches once. This time, it doesn't touch at all. This time, it touches twice. That's bad. This time, it touches once. So at any point for any number of vertical lines you draw, if it ever passes through or touches more than one point, it is not a function. This one is a function. I draw a vertical line, it touches once. I draw a vertical line, it touches once. I draw a vertical line, it touches once. So again, that is a function. It passes what's called the vertical line test. I can tell you're excited about that. Try these ones on your own. So go ahead and hit pause. Try these on your own. And hit play, and then we'll check your answers. Okay, number 5 is yes, touches once. 6 is yes, it only touches once. 7 is no, that will touch twice, that's a no. And then this one is a yes, it will only touch the graph once. That one would be a yes. So we got a yes, yes, no yes, 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 no yes. So hopefully you got those correct. 3 of them did pass the vertical line test. Okay, this kind of looks like almost like a machine, a camera. You put something in and it spits something out. So what we call the numbers that you put in, the input, are also called the domain of the function. The domain are all the x values. All the inputs represent the domain. The range is all what it spits out, your output. What you get out of something, a function, that's called the range. So the x values of what you put in are the domain. The y values of what you get out of it are the range. So for example, in this function, we input a 2, or negative 2. So if you input a negative 2 for x, your output is going to be a negative 6. So we would say for this particular graph that negative 2 is part of the domain, where negative 6 is part of the range. Okay? So I could write that as an ordered pair, negative 2 comma negative 6. This is my input. This is my output. And again, this negative 2 is part of the domain. This negative 6 is now part of what's called the range. Okay. So if we apply that to here, it says find the domain and range of the following. Well, when they just give you ordered pairs, it's sometimes easier just to write down your coordinates. So for this one, I've got negative 3, negative 2. For this one, I've got negative 1, 0. For this one, I've got, erase that, 1, comma 2. Erase that. And for this one, I've got 3, comma 4. So if we look at these ordered pairs, all of the first coordinates, these are x's. So I'm going to say that my domain, and sometimes you can just abbreviate the word domain with the letter D. Sometimes that is that's going to be the easiest way to do it, is we're going to say that our domain for this particular problem, or you just write out the domain, our domain is going to be, and I'm going to write these in what's called this kind of what's called set builder notation. So we're going to put these numbers inside of what are called brackets, or braces, not brackets, but braces. So we always go least to greatest. So my smallest domain value is negative 3. My next biggest domain value is negative 1. My next biggest domain value is 1. And my largest domain value is a 3. So we're going to say that that is our domain, negative 3, negative 1, 1, and 3. Well, that's the x values. The range, or R, is my range values. So we're going to do the exact same thing. We're going to put least to greatest. So negative 2 is my smallest, 0 followed by 2 followed by 4. So those represent the range. Okay. Now for this next one, it's a little bit different because all those points for A are just individual points. If you look at B, it's more like it's like a line. It's connected lines. They're not just like a bunch of individual points. So for this particular one, it's a little bit different. We're going to have to represent this in terms of using old knowledge. Remember how we just got done writing out our ands and ors? Well, this is going to be kind of like an and. So our smallest, if we think about coordinates here, the one that's farthest to the left is negative 2, negative 1. And our farthest point to the right is going to be, erase that stuff there as I spit all over the machine, is 3, comma 2. Okay. So we are saying that basically we are going from negative 2 is the smallest x to 3, which is our biggest x. And there are other x's in between. But if we write this in what's called interval notation, or in terms of writing it with intervals as far as a compound inequality, we're going to write it as an inequality. And we're going to write this as negative 2 is less than or equal to x is less than or equal to 3. We want to say that the x's are between negative 2 and 3, but we're including those. Those are those endpoints we're including. So that's why we need the equal to part. So this is part of our domain. So we could just go like this. This is part of my domain. Well, my range, again, so we go least to greatest. Least to greatest. So now let's do the range from least to greatest. Well, the smallest y value is negative 1. The largest y value is 2. And we're then going to write that one as a compound inequality. It's going to be very similar to doing the domain. We are saying that the smallest y value is negative 1, the largest y value is 2, and there are other y values in between. So we're going to write that as negative 1 is less than or equal to y is less than or equal to 2. So when the graph is connected, we want to write it with the compound inequality. When it's just a bunch of individual points, then you just write them out individually with commas. Okay. So knowing that, I want you guys to try these two on your own. And again, hit pause on the recorder and then just go ahead and try these two. Okay, for these ones, I'm going to go with, again, D for domain. And I'm going to write out all my x coordinates. So again, all my x coordinates for this particular problem, I'm going to have a -2. I'm going to have a -1. I'm going to have a 0. I'm going to have a 1. And I'm going to have a 2. Those are all of my x coordinates. For my y coordinates, again, my smallest y coordinate is a 0. And then there's a 2. And then there's a 4. Now, some of you are saying, well, there's two 2's. There's two y values of 2, and there's two y values of 4. Anytime you ever do domain and range, if there's a repeat in a number, you don't write it down twice. So if there's 2 zeros, you only put 1 0. If there's 2 2's, you only put 1 2. So just do not include any repeats when you're writing these out from least to greatest. Okay, well, those points were not connected. They are connected for number 10. So we're going to have to do number 10 differently than we did number 9. So for domain, my smallest x value is going to be, for this particular problem, my smallest x is 1, because I do have a point here that's at 1, 4. And over here I have a point that is 5, 4. So my smallest x is a 1. So I'm going to go from 1 less than or equal to x is less than or equal to 5. So my x's are going to go between 1 to 5. So there's other x's there that are in between. Obviously, there's a point here, there's a point here, there's a point here, there's a point here. So there's lots of x's, but we're going from least to greatest, and this is a continuous graph. So we say number 9 is a discrete graph. It's not connected. Number 10 is a continuous graph, so we have to include it as compound inequality. So this is what we want for domain, and then our range, really bad braces here. Our range is going to be, for this one, our smallest y value is a 0. And our largest y value is going to be 4. Okay? So we're going to go 0 is less than or equal to y is less than or equal to 4. Okay? Because this lowest point right here, that point is at 3, 0. So I have a y value of 0. Obviously up here, we have a y value of 4. So we're going to go from 0 to 4. And that's how we do our notation for domain and range. Okay, last couple slides and we're done. So this one says the function y equals -3x plus 12 represents the amount y in fluid ounces of juice remaining in a bottle after you take x gulps. So as you're gulping down your drink, more and more juice is going into your body and coming out of the container bottle that you have. So it says to identify the independent and dependent variables. Okay? Well, we haven't talked a lot about this. But an independent variable is simply going to be a variable that is including your input. So the variable that represents the input is the independent variable. Kind of helps you, independent variable and input. So the x values are the independents. The y values are the dependents. So as long as you know what is the x and the y's, you know what's independent and dependent. Because the y is dependent on x. You're always going to put numbers in for x, and you're going to get y's as your answer. So we're saying that y is depending on x. So that's why x is independent. You can just put those numbers in independently, but the y is depending on them to get, you don't get the y unless you are plugging in the x. So for this one, it says the domain is 0, 1, 2, 3, 4. Okay. So thinking about that, we want to be able to write out, in this particular case, we know the domain, we want to write out the range. Okay? So again, we are going to plug in 0, 1, 2, 3, 4 into that function. And whatever comes out is going to be our range. Okay? So if we think about this, again, just going back to our previous example, sometimes it does help to create like a little table. So if you want to create a table here, I'm going to create like a 3-column table. And basically, I'm going to put input, output, oops, it's a really bad O, output, okay? Again, remember, input is x, output is y. And over here, it's just going to be our equation, our function, -3x plus 12. So we are going to put in a 0, we are going to put in a 1, we are going to put in a 2, we're going to put in a 3, and way down here, we're going to put in a 4. So sorry for the very sloppy table. So if I put in a 0 for x, I've got -3 times 0 plus 12. you are going to get 12. If I put a 1 in for x, I'm going to get negative 3 times 1, which is negative 3, plus 12, which is 9. If I put a 2 in for x, I'm going to get negative 3 times 2 is negative 6, plus 12 is going to be 6. If I put a 3 in for x, negative 3 times 3 is negative 9. Negative 9 plus 12 is going to be 3. And finally, if I put a 4 in for x, negative 3 times 4 is negative 12. Negative 12 plus 12 is 0. So what I just did is I just found my range. My range is 0, 3, 6, 9, and 12. And remember, we always want to write range out from least to greatest. Okay, so we plugged in our x's, we got out our y's. Okay, I'm going to have you guys try this one on your own. So this will be your last, oops, or there is one more example, but your next to last example. So go ahead and hit pause one more time and go ahead and try to figure out what the independent and dependent variables are, and then we're going to find out our range. So go ahead and hit pause. When you're done, hit play again. Okay, for this particular one, obviously we have independent and dependent variables. Okay, so for this particular one, we are going to say that our A is our dependent, and that's going to be the number of avocados, and the dependent is going to be B, which is going to be the number of batches of guacamole. Okay, so batches of guacamole B, number of avocados A. So now I'm not going to make a table this time, but I'm still going to figure this out. So I know if I plug in a 0 for x, negative 4 times 0 is 0. 0 plus 14 is 14. So 14 is my range. Then I'm going to plug in a 1. If I plug a 1 in for b, negative 4 times 1 is negative 4. Negative 4 plus 14 is 10. So 10 is now my range. If I plug in a 2, negative 4 times 2 is negative 8. Negative 8 plus 14 is 6. So 6 is my range. And then finally, if I plug in a 3, negative 4 times 3 is negative 12. Negative 12 plus 14 is 2. So 2 is my range. So what again is my range? My range is 2, 6, 10, and 14. Okay. Last slide. Here's your exit ticket. Again, make an input-output table for the function using inputs. So one last time, go ahead and hit pause. And then I want you to fill out a table. Okay? And if you fill out the table, plug in negative 2, 0, 2, and 4. So go ahead and hit pause, and then come back and we will check your answers. Okay, so again, I'm going to put x for input, y for output, and negative 2x plus 3. And then if I plug in a negative 2 for x, I'm going to have negative 2 times negative 2, which is 4. 4 plus 3 is going to be 7. If I put a 0 in, negative 2 times 0 is 0, and 0 plus 3 is going to be 3. If I plug a 2 in for x, negative 2 times 2 is negative 4, and negative 4 plus 3 is going to be negative 1. And then finally, if I put a 4 in for x, negative 2 times 4 is negative 8. Negative 8 plus 3 is negative 5. So again, if you have the table, x is negative 2, y is 7, x is 0, y is 3, x is 2, y is negative 1, and x is 4, y is negative 5. So really, you didn't need the middle column. Technically speaking, all you really needed was this. So if I have my table, you could really just do x, y, and then do it this way. Negative 2, 0, 2, and 4. And if you want to just do it on the side or do the work in your head, you'll just make it look like this. So if x is negative 2, y is 7, x is 0, y is 3, x is 2, y is negative 1, x is 4, y is negative 5. And that is called an input-output table. Okay. So assignment, as you see, is page 108, 109, 3 to 22 all. As long as you tried these and saw how we did them, you should be fine on the assignment. Just make sure you have it done and brought back tomorrow. Thanks for watching this exciting video.